All right, so some of y'all have noticed the projects folder. You need to have a project in this class. I give you several examples if you want to come up with a different one that's totally cool. Let's go look at the documents and see what kind of things I suggest. All right, I've got several different ideas here. There's a Hangman game. There's a Mastermind game if you've ever played Mastermind as a kid. There's something called Pie Fighter. Well, I'm kind of interested in Pie Fighter, so I'm going to pop that one up. Now this one's kind of long, but if you've ever played one of those, role-playing games like Dungeons and Dragons or Python or something like that, something that where you roll dice in order to do conflict, then it may seem really familiar. So the way it works is, well, let's see. Pages 2 and 3 describe the rules for the combat. 4 shows a sample combat round. 5 shows a complete battle. 6 shows additional considerations. So what happens is your game will create 2 different characters, or 2 different fighters. And each one has a name, each one has a combat rating, each one has an armor. I don't know why that's called armors. Kind of need to remove the S there. And a number of attack dice. And so the name is the name of the character. The combat rating is the health of the fighter. If the combat rating ever drops to 0 or below, the fighter is defeated. Combat rating is also used to determine an attack bonus equal to 1/2 the combat rating. And then there's attack dice, which is how many dice you get to roll when you're attacking the enemy. And armor is how many points of damage is absorbed per roll. So you might have a fighter who looks like this. He's got a name. He's Conan. He's got a combat rating of 10. He rolls 5 attack dice, and his armor can soak up 2 hits. So what should the program do? Ask the user for the stats of 2 fighters. It should loop doing combat rounds until one fighter or the other is defeated, and then announce the name of the winning fighter. So then there's a sequence where you determine your attacks. You do your dice roll. You compare the attacks to see who's the winner and who's the loser. Whoever rolled the most gets the best. And then you calculate the damage. The damage is the difference between the 2 rolls. And then you calculate the real damage because armor can soak up some. And then you apply that damage to the losing fighter's combat rating. So I give a sample here, what it looks like when it runs. And I can even give you a program full of logic that's absolutely incomprehensible that demonstrates exactly what the program is supposed to do. It actually runs. It just follows logic that you won't be able to follow. You'd have to write your own. So that's that project. If that one interests you, that's great. Got some other ones. Hangman. We're pretty much familiar with the idea of Hangman. So, the game of Hangman could look like this. Let's play Hangman. I'm thinking of a word. It's 7 letters long. Guess a letter. Be careful. You can only make 8 mistakes. So you guess an A. So it prints out. Well, guess what the magic word is in this case, right? Something tells me it's Hangman. But anyways. Guess a letter, B. You could only make 7 more mistakes. Something's off here about that 8 and that 7. But anyways, you get the idea. They guess a B, it's wrong. You don't have to draw a picture of a hanging man or whatever. You just tell them, nope, you only have 6 more mistakes left to go. So they guess C. Nope, that was wrong. Lower that number a count. G, that's correct. N, that's correct. Now, if I was going to revise this a little bit, I would make it look a little bit better, but on the other hand, you could probably make it look a little bit better as well. And you keep guessing, each one lowers the number of mistakes you can make. Each letter you get right, pads it out so that you can see the whole thing, and finally you get it right. You've won. Play again? Yes, no. Okay, done. So, this one looks this one's actually a little bit more interesting than it looks when you get down to actually programming it. But what I would like for it to do is where I say it's up to you to decide how the program chooses a word, I kind of would like for you to read a file and pick a word from a file. Or at least have like more than, 2 or 3 or 4 words in it. Because if you had like a dictionary file that contained, 100 different words to play with, then that would be kind of neat. But that's not the most important part of the assignment. The most important part of the assignment is just getting it to play, Hangman, like that. And by the way, these are due in December, so they are semester projects. So you don't need to, get all worried and freaked out and try to write one, one of these tomorrow. Instead, I want you to actually put some time into it and to do a good job on it. Another idea, Mastermind. You may remember the game Mastermind from when you were a kid. You had these colored pegs. Look like that. And person, I would arrange my pegs in this order. You would take a guess. You would arrange your pegs, and then I would tell you how many you got right or how many you got wrong. A white peg meant that you had one of the colors right, but it was in the wrong place. And a black peg meant that you had not only the color right, but it was in the right place. I think this is kind of a fun one to program myself. It's a little bit challenging. You can download a Mastermind app for your iOS or Android device if you want to sit there and play Mastermind and familiarize yourself with the rules, which I, of course, list. Yeah. So, in this case, it'd be digits. Each place is a digit between 1 and 5. A digit is correct if it's the correct digit in the correct place. It's misplaced if the digit is in the code but not in the correct place. So let's play. So the computer's code that it randomly picks, but in this case I hard-coded it right, is 5432. And so we take a guess. Well, we type in 1, 2, 3, 4. Well, how many of these digits are right? Well, 5432, 432. There are 3 digits. Are any of them in the right place? 1, 1, 2, 2, 3. Okay, so there's 1 that's in the correct place. That 3 and that 3 in the correct place. So we have 1 in the correct place. And then there are 2 others that are right, but they're not in the correct place. So they're called misplaced. And so on. Using that information, if the player is clever enough, they can figure out, oh, well, that means this and that and the other, and they take some guesses and they finally get it right. I'd love to see some different project ideas. The only thing that I don't want you to do is to come up with a project so huge that there's no way you can possibly do it. So after a certain point, I'm going to ask y'all to upload a project description into that folder, so that if you're coming up with your own project, then I can eyeball it and say, well, I don't really know if you're going to be able to, program Crisis, in Python or something like that, right? Overwatch or whatever the cool thing is anymore. It needs to be something doable, but something interesting. And if none of these look interesting to you, then I want you to come up with your own idea. That's just something to tuck away, right? This is a semester project. It's not coming due in a couple of weeks, so you can put it away in your brain. I would like for it to look like you put some work into it, not just cranked it out in 30 minutes. It's possible that you're an awesome enough programmer, you could do one of these in 30 minutes, in which case, yeah, I'd be curious to see the solution. But I would like for it to look like you put some effort into it. If you can write it that fast, and put some additional polish in it. Alrighty. Well, another thing I wanted to move on to is, and I'm going to go ahead and load idle for this, I think. We talked a little bit about lists. And a list, and you don't necessarily have to type this. I think I'll just do it in the Python shell. A list is something like this. It's a series of values between square braces, like red, blue, green. And the series of values are all pieces of data separated by commas, like that. So if I print out that list, it says red, blue, and green. Well, sometimes you need to put things into a list. Like you need to ask the user for something. So what if we were going to ask the user for a list of numbers, but we wanted them to actually be stored in a list at the end of this? And what do I mean by that? Maybe we will do this in Python, but I'll show you what I mean. If I do this, n is equal to input, give me a list of numbers separated by, again, you don't have to type this, by commas. We will in just a minute. It's going to ask for some numbers. But then when I print n out, it's not a list, right? It's a string. A list is very specific. It begins with a brace. It ends with a brace. It has these values separated by commas. The good thing about it being in a list would be is you could access each one by one. Here we can't address them one by one, but we can split the list in order to get the data out and to play with it. So we could do something like this. N is equal to n dot split, and I want you to split it by the commas. And again, I'm not expecting you to get this 100% if you haven't already seen the split command before. But I just want you to tuck it away in your head that if you have string data and you need to turn it into a list, you can do that. And then once you do that, then it is a list. And you can process this with a for loop or something like that. Now, I'm going to give you an example of why we might want to do that. You probably know what an IP address is. An IP address is, there's several different ways of expressing it. But the most common IP addresses are known as IP4. They have 4 fields, 4 digits separated by periods, where each number is a value between 0 and 255. Yeah. Somebody tell me the fastest way to figure out my own IP address from the command prompt. ipconfig. Pardon me? Yeah, ipconfig is 1. Okay, so it's telling me that my IP4 address is 10.55.10.141. And a silly way you can find out what your address looks like to the external world is you can go to a site called iCanHasIP with a Z. iCanHasIP, and it tells you, now this is your IP address as it looks to the external world. Now that's different than what we saw over here, right? Because we have internal mappings of, private IP addresses inside our network. And then when we're accessing the external network, all of our computers, if you went to iCanHasIP.com on your computer right there, it would probably say the same thing. Tell me if that's true. Somebody else type that in. iCanHas with a Z, IP.com.
IP chicken doesn't fit.
Pardon me?
IP chicken.
Oh, yeah. Yeah. Okay, so a programming problem might say, given an IP address, I want to determine certain things about it, like whether it's a private IP address or not. Private IP addresses are values that have certain, certain of these digits have to fall within certain values. So one solution would be to turn this string into a list so that we can access each element individually. So I'm just going to show you that, and then I'm going to go on my merry way, and we're going to continue our lecture. So I'm going to make my new program, and I'm going to say ADR is equal to, and maybe I'll type in the one that I had over here, 10.55.10.141, whatever, 10.55.10.141, whatever. But then I wanted to turn that into some values that I can inspect. So I'm going to say IP is equal to addr.split, parentheses, quote, period, end quote, in parentheses. What that does is it turns this string into a list. And the list is of the form where the first piece of it would be a 10, the second piece of it would be a 55, the third piece of it would be a 10, and the fourth piece of it would be 141, which we could prove to ourselves. Let's write a little for loop that would prove that to ourselves. For x in range 4, parentheses 4 in parentheses 4, print x comma IP subscript x. Lecture I. All right, so when I do that, hopefully it's going to print 1055, 10141. And there we go. 1055, 10141. And this will make real good sense to you if, for those of y'all who have taken fundamentals and took it in Python and learned about arrays and things like that. If not, if this is all new to you, then just kind of tuck it away in your head that, oh, we're talking about lists now. And lists are such that the first value in it starts at index value 0. 1, 2, and 3. Because humans, when we count, we always start counting at 1. 1, 2, 3, 4. But computers, they start counting at 0. 0, 1, 2, and 3. So when I ran it, we see that element 0, is the 10. Element 1 is the 55. Element 2 is the 10. And element 3 is the 141. Now, what if I wanted to figure out if one of these values was equal to 128? Like if I wanted to know if this value, which would be IP subscript 0, was equal to 128. And what if I did this? If, and this is not going to work, it's going to be a syntax error. If IP subscript 0 is equal to 128, colon, print, whatever. The problem is that split did not convert it to numbers. Anytime you have a string and then you want to start doing math on it, like checking ranges or comparisons or stuff like that, then you have to convert them to numbers. And right now, it's not a number yet. So that should be a syntax error. Well, no, it's not a syntax error. But even if I tried to check it to 10 like this, it looks like it ought to be, right? Because that's a 10, so this ought to print yup, right? But it's not going to. Because they are not compatible types. One is a string. The data that's in the list is a string. And one is not. And yeah, and you might think, oh, I can fix that. I'm just going to make that a string. No, that's not the way to do it because, instead you would want these numbers to actually be integers. A couple of ways you could do that. I'm going to make a comment here. Convert a list of strings to a list of integers. This is one way. And then I'm going to show you a much shorter way. For x in range 4, parentheses 4 in parentheses colon, IP subscript x equals int parentheses IP subscript x. Now our list is all numbers. It is all integers because we used a for loop to step through from beginning to end to convert them. Okay, and so yeah, it agreed. Now then, yup, it equaled 10. There's another way to do that too. And this syntax will look dramatically new, even for those who took 113, most likely. And it's called list comprehension. And let me make sure that I have the syntax exactly right because I don't want to goof it up for y'all since I'm already going out, on a limb here.
Are you doing the if int bracket IP bracket?
Yeah, I'm going to use list comprehension, and it looks something like this. Let's do this. IP is equal to square brace int parentheses x in parentheses for x in IP in parentheses. This does the exact same thing as this. It looks completely different, maybe, but it does the same thing. What this does is this is known as list comprehension. It's going to build a list. That's why it's got square braces around it, because square braces define lists. And what this part does is it says, okay, I have a little for loop that's going to go from the first value in the IP list to the last value of the IP address. And each one of them is going to get run through this function to be turned into an integer. And then the result is going to be stored there. So either one of these will do the same thing. I'm going to just put some comments here. Convert list of strings to ints, and then convert list of strings to ints using list comprehension. So IP addresses are only valid if each piece of it is between 0 and 255. We might want to validate whether any of these are not equal, or not between those values. We could write a function that would do that. Since it's going to be a function, I think I'm going to use a DEF up here. So I'm going to do valid, or DEF, valid underscore IP, and it's going to take a list of values called IP. The first thing we need to see is whether it's exactly 4 elements long. Now, if you're taking a networking class, you know that also there are IP addresses that have 6 elements rather than 4. But in that case, you're smarter than me. I think I will call this valid IP4, though, just as a nod in that direction. And what I'm going to do is I'm going to run through the list, and if I find a value that is not between 0 and 255 inclusive, I'm going to return false. And then if I get all the way through it and none of them were wrong, then I'm going to return true. So, for x in IP, for every x value, for every value that's in that list, and this is a syntax that you can use in this language that you can't use in C, C++, Java, JavaScript, whatever. If 0 is greater than or equal to x is greater than or equal to 255, colon. No, I'm not liking it. I'm not liking the way that that worded out. So I'm going to say if x is less than 0 or x greater than 255, colon, return false because those are invalid values. And if it makes it through the entire list without returning false, we're going to return true. Another thing that I want to do is I want to make sure that it has 4 elements exactly. I need to check the length of the list. So I'm just going to have a check up above that. If len parentheses IP equals or not equals 4, then return false. So why not? If len parentheses the IP list is not equal to 4, return false. It's a bad IP address. It would be more fun to ask ourselves what the address was, right? Rather than just hard-code it in there. We should use an input statement. But then every single time we run this program, we're going to have to type something in. So I'm going to leave that alone, okay? But we have this function. Let's see if that's a valid IP address. So if valid underscore IP4 IP colon print, it's valid. Else colon print invalid. And if it's invalid, we probably actually want to quit the program or something like that. Yeah, I want to type something. Just a second. Sorry. So, if it's invalid, I'm going to quit right there. Is this a good way of handling it? No, but I just want you to see something that's doing some minuscule amount of error handling. We checked to make sure that it was 4 elements long, and also we checked to make sure that none of them was greater than or less than 255. Now it would be nice to print an error message, right? Saying what was wrong. So why don't we do that? Why don't we at least print out a reason why it didn't work? If we're going to return false, then we need to, in my mind, have some way of indicating to the user what was wrong. So in this case, I'm just going to print a message. Print IP4 address must be 4 values. And then I'm going to print a different error message if we return false here. I'm not going to print an error message if it returns true. Print. All right, someone who's familiar with networking, tell me what each one of these 4 components is called. What's that called? An octet? Okay, so each octet must be between 0 and 255. Alrighty, now here I am getting an error. Less than is not supported between instances of string and int. Why am I getting that? I already wrote some code to try to circumvent that, and I made a mistake. The mistake was that I started calling these functions on my IP list before I converted it to numbers. Right? It's still a list of strings. So I really need to move these calls, this if valid stuff, to down here after we have converted it to numbers. And I apologize, that was not an intentional mistake, but I'm going to highlight this business right here, if valid IP4, print it's valid, else print invalid quit. I'm just going to highlight that. I'm going to cut it, and I'm going to paste it down here at the bottom. All right, it should say that it's valid, right? Because I've typed in a valid value. Oh, what do you know? What else have I done wrong, guys? I bet somebody can spot it. It's complaining it doesn't know what true is.
Capitalized.
Yeah, in this language, unlike a great many others, you have to capitalize the words true and false. So this needs to be returned false with a capital F. That needs to be returned false with a capital F. And this needs to be returned true with a capital T. All right, so it's valid. And what if I made it wrong? Like what if I tacked on a 0.2 at the end? Well, now it's no longer 4 values, right? So, boom, it blew up. The IP address must be 4 values long. Your program is still running. Do you wish to kill it? Yeah, sure. Alrighty. That quit is probably not the best way to handle it. I'm going to remove that .2, but I'm going to test for the other error condition, which is like, what if one of these numbers was greater than 255? So instead of 10.55 whatever, I'm going to make it 1000.55 whatever. All right, this is really getting annoying. I'm getting tired of seeing that message, so I'm going to reword my logic a little bit. Here's what I'm going to do. I'm rewording the logic down here at the bottom, and then I need to stop and actually make sure that everybody else has got the typing okay as well. If valid IP address, we could do this, equals false. That's one way of doing it. Or I could put the word not in front of it. I'm going to pick one or the other. I'm going to put the word not there. So if not valid IP address, print. Please run again with correct data. Else, colon, print valid IP address, now continuing. Whatever, right? You know, we may not make it do anything, but all the rest of my code would probably be indented after this else from this point on. But if it was invalid, we're going to display that message. Otherwise, everything after that would need to be indented to be included within this else. All right, each octet must be okay. All right, it's too much to put on one screen, for which I apologize. So I may have to scroll up and down. Here's what the top of the code looks like. All guys watching at home, just pause it. That's the function that makes sure that it's exactly 4 values where every value is between 0 and 255. Notice I don't have any documentation. I don't have any comments telling any of this stuff, so this is pretty poor programming. And then down here, this is how we, I don't know why I have the word comment, convert a list of strings, right? So we had those two ways of doing the conversion, and then we called that function, passing in our converted number in list form so that we could print out an error message or a success message. All right, I forgot to resume it. So for you guys watching at home, we redid the if logic a little bit to make it look like this. You can do that if you want to, or you can skip it. What we did is we used ands and we used elifs. So if you feel like it, pause the recording and make your if logic look like that. All right, I've made one other mistake that I didn't mean to make, which is, do you remember when I said everything after this needed to be indented so that it wouldn't be run if we had incorrect data? Well, I forgot to do that. So all of this stuff from here down to the end needs to be indented so that it's lined up with the else. So I'm going to highlight it all. I could hit the tab key, or I could choose format indent. Either one works. Okay, so that's our little IP program. I think that's about enough to hopefully have illustrated some points. I'm going to be coming back to the topic of list comprehension. In fact, we're going to be doing lots with lists. So I'll just be hitting that topic again and again. So we have an exam coming up. It looks like it's postponed for a few weeks. It'll be October 4th, which is 2 weeks from this Thursday. It'll cover chapters 1 through 5 of the textbook. It's a textbook-specific quiz, so there should not be a lot of stuff in it that was only discussed in the lectures and not in the quizzes. But, you know, there may be some, so you will have been paying attention to the lectures all along.
Quick question.
Yes, sir.
When you say textbook, you mean the textbook you purchased or the one you use?
The one the purchase, the one that you do almost all your homework from, right? So the textbook, the quiz is written to the homework, and the homework is written to that exam. Excuse me, that textbook, right? The physical textbook. Okay, so for the online students, or for those who can't be there that day, it'll be open from October 3 to October 10. You can take it at the testing center, you know, down in the library, or you can take it online with ProctorU. If you take it with ProctorU, you're going to have a computer that's equipped with a camera and a microphone, you know, like a laptop. They all have them now, but if you don't have a laptop, then you'd need a webcam. So that might drive you to decide that you'd rather take it, you know, on campus. Let's see if I uploaded the documents about ProctorU yet. Yep. So if you go to content and scroll down here, you'll see some documents for ProctorU if you're going to take it via ProctorU. ProctorU pricing. So since somebody's going to sit there and watch you take it, they have to earn some money. So you'd have to pay them something. So the exam duration. Interesting. I did not realize that the amount differed on the length, but I guess that's up to you to pay. I mean, it's not like I tell them it's going to take, 2 hours and then it only takes you 30 minutes. I mean, I have some questions about that. Anyways, and then it also is less expensive the longer you schedule it away from you. When you go in, if you do take it now, you have to pay an $8.75 charge. If you take it soon, it's $5. Otherwise, if you schedule it, 72 hours away or more, then you don't pay those penalties. So about ProctorU. ProctorU is a unique service that allows test takers to complete exams, certifications, and assessments at their convenience while still maintaining exam integrity for institutions. Exams can be taken through ProctorU 24 hours a day, 7 days a week. The test taker is connected to a live person who guides them through the process and assists them with technical issues. So taking the exam, you go online to proctoru.com. You register, and then you'll see a list of available exams for our institution, and ours is pretty easy to spot. CIT 1203 midterm. And again, if you schedule it to be more than 72 hours away from your appointment, then you don't pay that penalty, otherwise you do. You can check your equipment to see what is required in order to take it. You can't take it with a Chromebook or an iPad. Apparently you have to have flash enabled. All right, well, that's kind of a drag. So I would install Flash and then try the test again. Anyways, you get to work through this before you pay them a cent because there's a link for it. Figure out if you can take it at home or not. What else are you going to need? A valid government issued or photo ID. Right. Campus ID would work. Having 2 is better than 1. If it's a webcam, if it's an internal webcam, you may need a mirror or reflective surface. So you better get one of those too so that the proctor can inspect the computer monitor edges. I've never done this. I've never taken a test with an online service like this, and some of y'all may have before. Okay, so anyways, you're going to want to go in to read all this. You're going to need a reliable computer running at least Windows Vista or Mac OS, a webcam or the camera built into the laptop, headphones or working speakers, a working microphone so that you can talk to the person who's proctoring the exam, a web browser with Adobe Flash Player installed. Wonder what they're going to do in the year 2020 when Adobe stops supporting Flash. Anyways, a reliable high-speed internet connection and the ability to allow video and screen sharing used to take the exam. So you better not be behind such a strong firewall that you won't be able to establish the appropriate connection with them. But you can go to this test site here and test your computer out. And I would bet that the majority of y'all are going to elect to take it on campus, but some of y'all, we have some people taking this class who aren't even in the same nation that we're in. So they will need to use ProctorU. All right, so I want to play more with the idea of lists, just because we were already on the topic. A list is something like this. It's a series of values, and this time I'm going to make a list that's just numbers, like that. And they are addressable via their index value or their subscript. So this is element 0, that's element 1, that's element 2, that's element 3, and that's element 4. So if you wanted to, we could say x is equal to list subscript 3. And what is that going to equal? Well, that's element 0, 1, 2, and so after this point, x will now equal 5. What if we change something? list subscript 0 is equal to 255. Well, now our list no longer looks like this. Our list now looks like 255.2.3.5.7. What if we want to add a value to our list? L.append, parentheses, let's add a new value to it. I'm going to add the value 1000 to it. And then I'm going to print my list again. What if I want to remove an element from it? Delete. Well, say I want to get rid of this value, which is a subscript 1. So I'm going to delete L subscript 1 and then print the list again. So it will no longer say, whatever. Let's run it and see what it looks like and see if that makes sense at all. Okay, so here we went. We changed the first element to 255, so it says 255.2357. Then we appended 1000 to it, so it says 255.2357 1000. Then we deleted the element at index 1, and so it became 255.357 100. So this is how you remove by position. You can also remove by value. List.remove, I really didn't like that 7. I'm going to make that 7 go away. So list.remove 7, parentheses in parentheses. Oh, and I forgot to print it, so I didn't see the change. Print L. Like that. So it found the 7 and deleted it. So the first one is a remove by position, or I could say delete by position. The next one is a remove by value. There are other methods to the list. This is a method. It's a method because we know it's a function that's attached to a variable. So append is a method. Remove is a method. Let's see if there's a sort method. What happens if we do L.sort? And then we print L. It sorted our data. What if we want to add 1 to the value of everything in our list? Well, again, we could use list comprehension, but let's not. Let's stick with the good-looking stuff. For me to do this, I need to know how many elements are in the list. And so I would use len to do this. So I'm going to use I to mean index value for I in range starting at 0, so 0, comma, len, parentheses, capital L, in parentheses, colon. Because if my list is 17 items long, I want to count from 0 up to 16. And so when you're using range, that means count up to but not including that second value. And so then we could say that list subscript 0 is equal to list subscript 0 plus 1. We're going to add 1 to every value in it. And now let's print it out again. Print list. I can't say that it added. Oh, I did something real dumb. Who's the first to see the error? I wanted to change every value in the list. So is 0 a good thing to be putting there?
No.
That should be the letter I. It should be my index counter. So replace those zeros with I's, because I don't want to just keep doing that to the first one over and over and over. I want to do it to every one of them in turn. And so it was 35 1000. It became 46 256 1001. What if we want to add up all the values in that list? Here's the shortcut. Total is equal to sum, parentheses, list. end parentheses. Or we could write a loop to do it. What if we want to find the biggest one? Big is equal to max of everything in the list. So max parentheses L. Small is equal to min parentheses L. And we could write the loops that do the same thing, but we did that last class period. So let's do that. I want to look something up. Sorry, guys. Okay. So what we're going to do is we're going to say print total is all right. Total is equal to, and we're going to use curly braces here because what we're doing is a formatted print here. Formatted print allows us to specify which values go into which place in a print statement. So total is equal to curly brace 0 in curly brace, comma, biggest equals curly brace 1 in curly brace, comma, smallest equals curly brace 2 in curly brace. This is my formatting string, and then after my formatting string is done, I'm going to put a close quote followed by a dot format. So quote, dot, format, and I'm going to give it the 3 values that I want to fill into these 3 placeholders. So 0 is going to get the total variable. 1 is going to get the big variable. And 2 is going to get the small variable. And I've already almost goofed. I have 1, 2 close opening parentheses, so I need 2 closing parentheses as well, and I've only got 1. So I'm going to go back over here and add a second closing parentheses and then run it. Okay, so hopefully it worked. I mean, I can guess that that total is correct. 1001 does in fact look like it's the biggest. Smallest is 4. That all looks valid. This is a way to traverse a list by index value, but you can also traverse it not by its index, but by its actual value, in which case you do something like this. For v in list, colon, print, parentheses, v. That's how to print the list out by value. If you want to print it out by index, you do this. For I in range, subscript, len, subscript, I said subscript, excuse me. I in range, parentheses, len, parentheses, capital L, in parentheses, colon, print, parentheses, capital L, subscript I, in subscript, in parentheses. Both of these do the same thing, just that one's a shorter syntax. I like that one better. But I did not use this one in this case because if you change the value of v, it's not going to have a permanent effect. Like if I go in and I sneak in here and I want to set every value in my list equal to 3, that should not actually work, and it didn't, which is actually a good thing. So when you're stepping through it by value, this variable is just a copy of what was originally in the list, and you can't make any changes to it. If you want to change the value, you have to access it by index. And so that's why I did it like this. I accessed it by index. Note that when you're using a range, if it begins as 0, you don't have to put the 0 comma there. The first number specifies where it begins, but if it's beginning at 0, that's such a commonplace thing that we could just get rid of that. Or we can leave it. I kind of like seeing it. But I skipped it down here. So I could put 0 comma there, or I could leave it out, just to indicate the same thing. If you put a third number in, it means how much it increments by each time, or decrements by. So if I put comma 1 there, it'll count 0, 1, 2, 3, 4, 5, 6. But if I put in a 2 there, it would count 0, 2, 4, 6, 8, and so on. So this is the longest form of that statement. And this would be the shortest form of that statement. Like that. They actually do the same thing. It's just that we're not specifying a starting position, so it defaulted to 0. And we're not specifying a step, right, how much to increment it by each time, so it defaults to being 1. All right, that's about enough of that. Lists are so important that I don't mind us hitting the topic again and again and again and again as we go on. So let's stop here. Anybody, I'll stop the recording and ask if anybody has typos or if there are any questions. Are there any questions over this or the projects or anything? Nope. All right.